The map was supposed to reveal differences. Instead, it kept showing the same sky. North looked almost identical to south. One side of the universe looked almost identical to the other. Only then does a spacecraft called COBE reveal what may be the strangest image ever captured of the cosmos. At first, there is every reason to expect differences. If the universe built galaxies, clusters, and enormous structures unevenly, those fingerprints should still be visible. Some directions should stand out. Others should look different. But as the map fills in, the expected differences refuse to appear. The enormous canvas of the universe appears remarkably balanced. The enormous canvas of the universe appears remarkably balanced. The result creates an immediate problem. Everything visible in space is uneven. Galaxies gather into groups. Clusters gather into larger structures. Matter is clearly not distributed perfectly today. Yet the oldest view of the universe seems to show almost none of that imbalance. The sky looks smoother than expected, more uniform than expected, more orderly than it has any obvious right to be, and that raises a difficult possibility. If the early universe really began this smooth, then the visible differences needed to build everything that came later seem almost impossible to find. The universe suddenly looks too balanced for its own history. The obvious escape route is still available. Maybe the map is incomplete. Maybe the measurements are too rough. Maybe larger differences are hiding somewhere the survey has not captured yet. So the scanning continues. The same sky is measured again and again. Each new pass adds more detail, more coverage, more opportunities for hidden irregularities to appear, but they do not appear. Instead, the opposite happens. The tiny differences already visible remain tiny. The brighter regions are only slightly brighter. The cooler regions are only slightly cooler. Across the entire sky, variations are measured in millionths of a degree. The map begins to take on a strange appearance. Small ripples exist, but the enormous contrasts many expected never emerge. No giant hot regions, no massive cold zones, no hidden sections suddenly revealing a radically different universe. Every additional observation removes another place for that explanation to hide. The problem is no longer that the universe merely looks smooth. The problem is that repeated measurements keep confirming it. What first seemed like a possible observational mistake starts losing ground. Better observations are not uncovering large differences. They are making the overall picture harder to escape. The universe keeps looking balanced. Every new scan removes another place for hidden structure to hide. And with each pass, a more uncomfortable possibility takes its place. If the imbalance was genuinely this small from the beginning, then somehow those tiny ripples had to become every galaxy, every cluster, and every large structure visible today. The map is examined again, but this time, the focus shifts. Not to the overall smoothness, to the tiny imperfections hidden inside it. They are easy to miss at first. Small warm patches, small cool patches, slight variations scattered across a sky that still appears almost perfectly uniform. Yet those tiny irregularities change the interpretation immediately. The universe no longer looks completely smooth. It looks mostly smooth. And that difference matters. What it seemed like a fatal problem begins to look more manageable. The fluctuations are small, but they are not zero. The map contains faint traces of imbalance after all. A new possibility starts taking shape. Perhaps those tiny differences are exactly what the universe needed. Given enough time, slightly denser regions could gradually pull in more material. Slightly less dense regions could fall behind. The process would begin almost invisibly, then slowly widen over immense stretches of time. For the first time, the contradiction appears to have an answer. The galaxies, clusters, and larger structures visible today may not require dramatic beginnings. They may have grown from these faint patterns already present in the earliest map. The universe still looks remarkably uniform, but now the small irregularities seem less like noise and more like origins. For the moment, the crisis eases. The sky appears balanced because the differences were never large. They were simply very small, and perhaps that was enough. For a while, the explanation holds. The tiny fluctuations remain visible in the map. They provide a starting point, a place where growth could begin, a reason to believe that the smooth early universe was not perfectly smooth after all. Then the comparisons become more demanding. Researchers place the early measurements beside the universe that actually exists. On one side sits the ancient map, almost smooth, almost featureless. On the other sits the modern universe. Galaxies gather into clusters. Clusters gather into larger structures. Vast patterns stretch across space in every direction. The contrast starts creating pressure. The modern universe appears crowded with structure. Matter gathers into complex patterns at every scale. The cosmic landscape looks rich, uneven, and deeply textured. The early map still looks almost flat. The fluctuations are there. No one doubts that. The problem is what they are expected to become. Again and again, the comparison points in the same direction. The irregularities visible in the beginning appear extraordinarily small compared to the structures that eventually emerge. The comfortable answer begins losing stability. What once looked like a complete solution starts looking incomplete. The fluctuations explain where growth could start, but the scale of what forms later remains difficult to reconcile with a beginning that appears so remarkably uniform. The original contradiction returns in a new form. The universe is not merely smooth. It appears smoother than its own history seems to allow. The focus of the problem shifts. The question is no longer why the sky looks nearly identical in every direction. The measurements have already shown that it does. Now the challenge is explaining how such a balanced beginning produced a universe filled with galaxies, clusters, and enormous structures. Something allowed those tiny irregularities to become far more than they first appeared. And whatever that process was, it has become impossible to ignore. The image itself never changed. Its meaning did. The map still shows a sky that is almost perfectly uniform. The vast majority of it looks the same in every direction. The balance remains. The smoothness remains. But the meaning changes completely. Those faint irregularities scattered across the map are no longer just small imperfections. They become the starting conditions for everything that follows. Every galaxy, every cluster, every large structure spread across the visible universe. All of them trace back to differences so small they were almost invisible against the larger background. The original contradiction begins to dissolve. The smoothness was never evidence that nothing could happen. The smoothness was the environment in which nearly everything happened. What made the universe remarkable was not the size of the differences, it was how small they were. The sky does not look different because the early universe was almost perfectly balanced. The galaxies were not missing from that picture. They were hidden inside differences so small they were almost impossible to see. Nearly everything visible today emerged from variations that barely stood out against the background at all.